Now we have all the tools that we need to finally address this application that I have mentioned several times, which is how to value the impact on a consumer well-being of introducing a new product in the market. And I want to describe how this is done using a hypothetical example. So it's an example that I'm inventing, but based on what I will consider non-crazy data. So suppose that about 10 years to 12 years from now, you're carrying this exercise in the market for household robots, and you find the following data. You find that in 2020, the price per robot, per household robot, was $9,000, and that the amount of robots that this particular consumer, which we should think of as a typical average US consumer, was 1. And that 5 years later, into 2025, as you keep track of the market, the price of robots, due to the amazing work of many people like the students in this course, has dropped down to 1,000, and that the typical average US household consumes 9 robots. Now, how would an economist use this data to compute what is the impact of the introduction of this new product called household robots into this particular typical consumer well-being? So the first thing we can do is notice that, as we have argued before, we can use this data, which is a price of 9,000 and a demand of 1, and a price of 1,000 and a demand of 9, so we have 2 data points like this. We can do that using econometric methods to estimate the demand. And just for simplicity, suppose that you estimate a linear model, so you find the line that passes through both points. That seems to be the best prediction. And by the way, you will learn about how to do this precisely if you take more advanced economics courses. Now, what is the equation of this line that suggests what is the demand of the consumer for these robots as a function of P? Well, from basic geometry, and you can easily see that this x star of P is equal to the max of 0, 10 minus P divided by 1,000. In particular, it crosses here at 10,000 and it crosses here at 10. Now, what is going to be the value of introducing the robots, given that they're going to sell at price P? Well, the key insight of this type of economic analysis is that you can think of the value of introducing the products as what is the change in consumer surplus from a situation in which the price is infinity, so it's so high that the robots are never purchased. So if the price is infinity, you don't really care if the robots are not purchased or don't exist, you just don't get to consuming, to a situation in which the price is the observed price, trace P. So this is going to be equal basically to the difference in consumer surplus at P minus the consumer surplus when the price is infinity. But remember that this is a situation in which you don't purchase anything, so you consume an amount of x equals to 0, so this is just 0. So the insight is that we can think of the value of introducing this new product just as the consumer surplus of the new product at that price. So let's think for a second in this particular example about what is the consumer surplus at both dates. So what is the consumer surplus in 2020? Well, we know that the price in 2020 is this. So we know that the value of the new product in the robot is going to be this area, that consumer surplus, and that is just 1/2 times 1 times this height, which is 1,000. So it's just $500. Now, what is the consumer surplus in 2025 when the price has gone down? Well, you should be aware from now that given all that we have learned, that is basically that triangle. And that is going to be 1/2 times 9, which is that distance, times 9,000. And that is going to be equal to 40,500. So notice that the surplus is $40,000 higher when the prices are at 1,000 than when they are 9,000. Let me conclude this section or this video with several remarks that I hope you find interesting. The first one is that these are hypothetical numbers. I made them up, but they're not crazy. I wouldn't be surprised if numbers, when this happens, look kind of like that. So you get a feeling, think of this as a glimpse into the future of this market that I'm making up. The second is that it's interesting to compare the difference in the consumer surplus about dates versus the total sales per consumer. So notice that in both cases, total sales are equal to $9,000. Here, there is only one robot bought at 9,000, here 9 and 1,000. And yet, when the price is high, so the consumer has barely started demanding anything, the consumer surplus is small relative to total sales. By the time the prices have gone down, and they're very close to zero, the consumer surplus is very large, and it's actually several times the total sales. Why am I illustrating this to you or highlighting this to you? Because I want you to understand that the value of introducing a new product like these household robots is really going to depend on the price at which they are sold. And clearly, as the price goes down, as technology gets better and they become cheaper, the value of having introduced the technologies keeps increasing. And not only keeps increasing because the value of the new product is this area that keeps increasing, and areas increase with the square, every time the increase in the value of the new product goes up with the square of the decrease of the price.